70,000 years ago, a star named Scholtz star came within 0.83 light-years of the solar system. Had it possessed a higher solar mass than its 15%, or travelled at a velocity less than its considerable 50 miles per second, its gravitational influence may well have been disruptive enough to affect the relative stability of our solar system. In astronomical terms then, this was a close shave, but it does beg the question: have any passing stars been disruptive to the solar system in the past? And are there any stars lurking in our corner of the galactic neighbourhood that could pose a threat to the relative stability of our solar system? Every 250 million years, the Sun completes a full orbit around the centre of the galaxy, a journey it has undertaken for the last 4.5 billion years, completing 18 revolutions. On this journey through the galaxy, almost all the other 2 billion or so stars revolve around the galactic centre with us, where their positions relative to the Sun typically remain unchanged. However, there are some stars whose directional speed of movement is different to the Sun, which leads to trajectories where stars inevitably cross paths with it. Charting the positions, distances, motions and properties of these stars is therefore of importance to astronomers, so that simulations can be made about the impact these travelling stars have on the solar system, both in the past and into the future, a task that has been made considerably easier by the launch of the Gaia Telescope in 2013. Gaia's primary mission has helped create a highly detailed 3D map of over 1 billion stars within the Milky Way, allowing astronomers to analyse highly accurate data from which simulations can be run back and forward in time, giving us the ability to see which stars came close to the Sun in the past, and which, if any, may pose a threat to the solar system in the future. And it's surprising how frequently this does happen. At 4.2 light-years, Proxima Centauri is currently our nearest neighbour. But this status changes regularly, as it is estimated that every 50,000 years a star will pass between it and the Sun. In fact, some have passed us closer than 3.2 light-years, such as Scholtz star, which upon its discovery in 2013 was considered the closest a star had ever passed by the solar system. But with new data from the Gaia Telescope emerging, we now know there have been other instances where stars have come even closer in the not-too-distant past. One of these stars, HD 7977, now almost 247 light-years away, did so 2.8 million years ago when it crossed a mere 0.49 light-years from the Sun. At this distance, it would have been well within the Oort cloud, and with a solar mass of 1.07, it would have had considerable gravitational influence on any objects around it. As such, it disturbed the motion of many of the icy objects within the Oort cloud, ejecting some into interstellar space, whilst others were flung towards the solar system, ending up as long-period comets, such as the recently discovered comets of Hale Bopp, Hyakutake and Lovejoy. These comets have orbital periods ranging from a few thousand to several 100,000 years, and may be the result of encounters Oort cloud objects had with passing stars such as HD 7977. But what about the future threats to the solar system? We've known about the trajectory of Gliese 710 since 1996. But it's only recently, with the data from the Gaia Telescope, have we been able to narrow down and refine the impact this star will have on the solar system. It's currently located 62.3 light-years away, hurtling towards the solar system at a velocity of 9 miles per second. Predictions based on the data from the Gaia Telescope suggest it will come closest to our solar system in 1.29 million years, where it will pose a significant potential threat to us. If we are still around in this distant future, humans will be able to visibly see this star with a brightness similar to the planet's, as it will be a mere 0.15 light-years out from the Sun. But this close, and with a solar mass of 0.6, its gravitational influence will be significant enough to cause the solar system some problems. Gravitationally, the orbits of the planets will remain unaffected, and the effects on Kuiper Belt objects will be negligible. It's simply too small to perturb the orbits of planets. But, as it passes through the Oort cloud, its gravitational influence will be able to perturb the icy objects within it. The knock-on effect will be showers of comets headed toward the solar system, where it is estimated future humans will see 10 naked-eye long-period comets per year. A spectacular show for sure, which is expected to last for 3 to 4 million years, bringing with it a heightened risk of impact events here on Earth. In the words of the astronomers who wrote the science paper supporting this view, it will be the strongest disrupting encounter in the future and history of the solar system.